In this segment, we'll talk about finding the limit of a function which is given in a rational form. So here we have the question given to us. The statement is saying that, hey, you want to find the limit of this particular expression as x approaches 5. If we look at the numerator, at x equal to 5, your x squared minus 2x minus 15 will be equal to 5 squared minus 2 times 5 minus 15, and that gives us 0. And same thing for the denominator at x equal to 5. When you look at x minus 5, that gives you 5 minus 5, that gives you 0. So what are you trying to find? What you're saying here is that you have like a 0 by 0 form. And again, we can apply the L'Hopital's rule to find out what the limit is. So in this case, so what does L'Hopital rule say? L'Hopital rule says if f of a is equal to 0, g of a is equal to 0, then the limit of f of x divided by g of x as x approaches a can be written as f prime of a divided by g prime of a. So you could, if both of those are defined, f prime of a as well as g prime of a. So let's go and see that if that is the case. Here what we have is that f of x will be your x squared minus 2x minus 15, and g of x is your x minus 5. So let's go and see whether that is the case. So what we have is we have limit of x approaching 5, x squared minus 2x minus 15 divided by x minus 5. So we can say, hey, this is same equal to limit of x approaching 5 because we want to apply the L'Hopital's rule to it. We can take the derivative of the numerator. We can take the derivative of the denominator. And what is the derivative of the numerator? It is 2x here and minus 2 here. So the 2x minus 2. And of course, the derivative of 15 is 0. Derivative of x is 1 and derivative of 5 is 0, so that's what we get. So if we put now, if we look at x approaching 5, 2x minus 2 has a finite value, 1 has a finite value. So we can just substitute the value of 5 for x and be able to get what the limit is, in this case being 8. So we apply the L'Hopital's rule to be able to find out that the limit of this expression is 8. Now it's quite possible to do the same problem by possibly being able to factor the expressions. So we have x squared minus 2x minus 15 divided by x minus 5. If we look at the top expression, we can find the zeros of this function by using the quadratic formula, or just by observation we can see that, hey, I can rewrite the numerator by x minus 5 times x plus 3, because that gives me x squared minus 5x plus 3x and minus 15, and again divided by x minus 5. So this and this cancels out, so this limit will be as x approaches 5, I'll get x plus 3, and since this is a quantity which is finite at 5, so it'll be 5 plus 3, and that gives us 8. So we're getting the same limit as we got from the L'Hopital's rules as we're getting by factoring out the numerator and canceling with the denominator as it's possible in this particular case. So either way, you can be able to solve the problem of finding this limit. And that's the end of this segment.